Welcome to 10 Minutes with Harry. For my next 3 sessions, I would like to talk about Wenckebach AV block. The first will be on the footprints, the second on the clinical features, and the third is atypical Wenckebach, as we usually see it on the electrocardiograph. Today, I would like to talk about the electrocardiographic spectrum of Wenckebach AV block. And my first talk will be on the footprints. But before we start, who was Wenckebach? Karel Frederick Wenckebach was born in The Hague, Netherlands, and completed his medical degree in 1888. 10 years later, he saw a patient in her early 40s who had an irregular pulse. Wenckebach decided to investigate this, but he did not have the electrocardiograph, which Eindhoven in 1901 had the first report of this, but it wasn't clinical until a few years later. But Wenckebach worked out the relationship of the atrial and ventricular contractions by using the carotid pulse as well as the jugular venous pulse. In the jugular venous pulse, there are 2 waves, that which belongs to the carotid and that of the atrial contraction. So we have atrial and ventricular contractions. And when you can see here, there is A and C, there is a short distance, there is in the next beat a longer distance, a third beat, a longer distance again, and then there was a drop beat. A 4-3 Wenckebach sequence. And then this repeated itself again. He was able to say, therefore, that for every 4 atrial contractions, there were only 3 ventricular contractions. This was called type 1 second-degree AV block, Wenckebach or Mobert's type 1. A few years later, Hay described type 2 second-degree AV block, which is Mobert's type 2. And remember, Hay also did not have the electrocardiogram. It wasn't therefore until 1924 that Mobert's classified this type of block using electrocardiographic criteria. In summary, Wenckebach or Mobert's type 1 is a progressive lengthening of the PR interval with a drop beat. And it is predominantly in the AV node and therefore a narrow QRS, but can also occur more distally. Mobert's type 2, however, the PR interval remains constant with the drop beat, and it is always in the distal conducting system. I will describe the ECG footprints of a Wenckebach sequence as either typical, absolute, or atypical. The first 2 will be the subject of this talk. So a typical Wenckebach sequence, as you can see here on the electrocardiograph with a red highlight, there is progressive prolongation of the PR interval with AV node fatigue. The first PR interval is 210 milliseconds, the second 380, and the fourth one 540 milliseconds. There is then a non-conducted P wave, and following this, the AV node rests and conduction returns. One of the other features that make this typical is that the greatest increase in the PR interval is typically between the first and second beat, with the increment increase of each conducted beat becoming shorter. So if we go back to our illustration again, the first PR interval was 210 and the second 380. The difference was 170 milliseconds, whereas the next one at 540 made the difference between 380 and 540 only 160 milliseconds. And this is the typical classical feature of this. And we can, as a result of this, the RR shortens from 1010 to 1000 milliseconds because of this 10 millisecond difference. The absolute feature is something that I always use and is not necessarily stressed in the literature. Again, we have the last beat before the drop beat. The PR interval is actually longest. Then we have the non-conductive P wave and the drop beat, and then the PR interval is shortest immediately after the drop beat. Why is this important? Well, when we look at Wenckebach sequences in everyday ECGs and Holter monitoring, these three features are the features that make us understand and diagnose Wenckebach. The progressive prolongation is also important, but is often not seen. Thank you very much.